Hello, my friends. This is part 3 of my award-winning zero-view series on option pricing with the binomial option pricing model. In this video, we're going to extend the previous 2 videos to have two-step model. We're going to consider how to price European options under this framework. So basically, the two-step model is similar to the one-step model, except now we have an extra step. So just for example, let's say the initial stock price is 20. You can either double, so you can go to S0 times U, so 20 times 2 is 40, or you can halve. You go to S0 times D equals 20 times a half equals 10. And then if you're at this node, you can double to 80 or half to 20. Or this node, you can double to 20, half to 5. And note that they combine whether you go up and then down or down and then up, because U equals 1 over D. 2 is equal to 1 over a half. So they go to 20. So this is a connecting tree. So our goal is to show how to price a European put option or any option. In this framework, we're going to assume that the whole time period is a year. So H will be a half. And the idea is we know the terminal payoffs, and we're going to go backwards in time until we get to the initial node to get the option price. So to say it a little bit differently, let's first of all, let's give you some values in this example. Let's say the initial strike price is $20. The initial stock price is 20, and you can go up and double, or you can go half the value. So U is 2 or D is a half. And let's also add the risk-free rate. The reason I want to make it non-zero is because for put options, for American options, it will make a big difference. So the risk-free rate is going to be ln 1.025 squared, so about 5%. The reason for this weird value is it'll make my life easier with the math. So if this is the risk-free rate, then $1 grows from 1 to e to the RH in one period of length h. So if h is a half a year, this means it'll grow to e to the 1/2 times r, which is ln 1.025 squared, and you can simplify this into just 1.025. Okay, so these are the parameters we have, the variables. So the idea is we want to price a European put option with strike 20. So we know the terminal values, right? So if the strike is 20, then if the stock price is 80, then the put is worth 0 at this node. If the stock is 20, the put is also worth 0 at this node. You notice I made my life easier by making a lot of things 0. But if the stock goes down twice in a row, then the stock goes down to 5. And if the strike is 20, then the put is worth $15, right? So here's the only time where the put is in the money. So we want to go backwards in time. So remember, in the previous videos, we said that there's like some real world probability that you can go up and down, but that probability doesn't matter in option pricing due to no arbitrage and replication in a complete market. So as long as the probability is strictly between 0 and 1, the probability doesn't matter. But we can construct what's called a risk-neutral probability that kind of looks like a probability, and then we can do a discounted expectation under this risk-neutral probability. So just to remind you guys, in the previous video, we showed that this probability is basically e to the RH minus D over U minus D. So basically, we can do the math, and we get that this risk-neutral probability is 0.35. So we can basically price the option as a discounted expectation under that risk-neutral probability. So let's first do the easy step where we're going to do this internal node. So this internal node, I have it V1, the option at time 1 equals VU because it went up, and it's the discounted, so e to the negative RH, times this risk-neutral probability, P star, times VUU if you went up twice, plus 1 minus P star times VUD if you went up and then down, and both of those are 0, so the value at this node is 0. Now, what is VD if you go down the first time? Well, we're going to do the discounted expectation under that P star, the risk neutral probability. So the first one, of course, is still 0. Notice I made my life easier with the math. And the second one is 15, right? So 1 minus p star is 1 minus 0.35, and then times 15, because that's, if you go down twice, that's the value of the option. And then we multiply it by e to the negative rh, which we showed above was 1 over 1.025. So once you do that, and I showed all my work, and I'll put this on the website, it's you get that, you get this thing, you get 9.51 is the value at this node. So you have 0 is the value at this node, 9.51 is the value at this node, and then you kind of repeat the process. You go back to this node, the root node. So so you still have the discounted expectation, p star times 0, and then 1 minus p star times, that should not say 0, sorry guys, that should say VD, if you went down. So basically, it's e to negative RH times 1 minus p star times VD. And VD we previously calculated as 9.51, so it's 1 over 1.025 times 0.65 times 9.51 equals 6.03. So the no arbitrage price of the option is $6.03. So we basically went backwards in time and did a discounted probability under the risk neutral measure. And in the previous video, I showed you with the replicated portfolio, you can derive the risk neutral probability. P star is e to the RH minus d over u minus d. Okay, so then you get the value as $6.03. Okay, this should have not been 0. This should have actually been 9.51, but I messed up. I will fix that in the video. Hope you enjoyed. The next video will be the same thing, but American options, where you can exercise early. Thank you guys so much. Peace.